Hello. With a bit of luck, this should all work. Hoi Sander. Still working on getting everything a bit properly set up. Hello to everyone who's joining us for our live stream. We'll be starting in 6 minutes. Hello everyone, welcome to the Tygron webinar live stream. We'll be starting in about 3 minutes. Good afternoon everyone. I believe we have a few people joining in watching us today. Welcome to the Tygron webinar on networks. My name is Rudolf and today I am going to be telling you about networks in the Tygron platform and network generation. As a quick starter and overview, when we talk about networks, especially in the context of the Tygron platform, we're actually talking about like the resource distribution networks, such as electricity, gas, and internet. To start, we'll begin with a basic explanation of how these networks are implemented in terms of basic components. Then we're going to look at creating our own network through the network generation tool. And finally, we'll look at some of the options available for analyzing the state of a network and what that could mean for your project. Let's first talk about how a network works. If you look on screen, you will see a very basic network setup. Networks consist of multiple types of data, most of which are visualized already here. It's built up in the basis from a series of nodes and lines. So if we zoom in a bit, we will see that there are a couple of junctions marked with these white dots. Those are nodes. And any pair of two nodes can be joined together with a line. That's the yellow line that you see in between. The yellow line represents the cable or the pipe through which the resource can move. And the nodes are basically just the definitions of the endpoints of individual pipes. Every node will connect to two or more pipes or cables. So for example, we have this junction here, which is only connected to two lines, one coming in and one going out. We also have one over here. You can't see the white dot, but there's one over here, which is connected to three lines. It's also possible that there's a node with only one line connecting to it. In those cases, the node is considered an end node and will be treated a tiny bit specially. So this describes the geographical layout of a network. And then added on top of that are the loads. Those are the red dots that we see marked here. And loads are basically the definitions of where a certain resource is either produced or consumed. Nodes are always placed attached to a specific, loads are always attached to a specific node on the network. The load is basically just a definition of how much of a resource is produced or consumed in that location. And the definition is attached to a specific node. So for the purposes of calculation, the definition of how much resource an endpoint takes, this node carries that definition with him. Also important to note, loads can only be attached to the endpoints of networks. So all of these lines connect to nodes which connect to more lines until they reach a certain end, and at that end there should always be a load. That forms the basic layout of the network. Then looking at some of the definitions that are associated with it, every network has a specific attribute associated with it, called the transport attribute. And this basically defines the name of the attribute used to indicate how much of a resource is moved through the network. It's defined on a network level because it is used for both the loads, the endpoints, the producers and consumers, and the lines to define how much of a resource is moved through them. Looking at the loads, I'm aware, by the way, that you cannot see the drop down that you see when I hover over this. That's an issue with our streaming setup right now. Apologies for that. If you hover over networks, we have a drop down. One of the options there is show loads. If I click on that, this panel appears on the left hand side. And here we have an overview of all the loads in this network. So I have 5 loads visually here, and I have 5 loads here on the side. And every load has been given a flow attribute indicating how much of a resource it consumes. Negative number conventionally means consumption. This one uses 100. This one uses 350. This one uses 250. And we have one producer on the network, that's this one. That one produces 1,000 of a specific kind of resource. So every load has a definition of how much it uses or how much it produces. On the network, exactly one load should be defined as the root. In my example, that's this load here. The root load, being a root load in and of itself, doesn't mean anything special, but it provides an anchoring point for our built-in calculations so that it can be calculated. If this load does indeed take up a certain amount of a resource, and this load does indeed take up a certain amount of a resource. How much of that resource needs to flow through each one of the pipes? The calculations performed are always grounded in one central load, and that's defined as the root load. If the entire network is structured as a tree, you won't see much difference depending on where you place the root load. However, there are some structures possible where there are like cycles in a network, lines which connect back to other lines. And in those cases, placing the root load in a different location will mean that the flow through the network occurs in a different means. All the loads also have a certain state. The state basically means whether that load is connected, active, or as we call it, ready, or inactive or not connected, or as we then call it, nothing. So ready means it's connected, and nothing means it's not connected. So this is our network. This is one that I have already predefined in our editor for demonstration purposes. And it already has a couple of properties. There are a few loads which consume resource. There's one load which produces resource. And almost all of the loads are active except for this one, which I've made inactive. And this one as well. Now defining it in the editor, all of the loads and all of the lines are visible so that you have some hold on editing it. If you couldn't see them, you couldn't edit them, which would be silly in an editor session. If we start the test run, and there we get one of those beautiful fly-throughs, which I'm skipping. If we start the test run, then the network will actually be calculated, and how much resource loads produce and consume and what loads are active and inactive actually affect which parts of the network are made visible or invisible. So looking at the network right now, this was our producer, and here are two consumers, and we see that there is resource flow from our producer to those two consumers. But there were also two consumers on this side of the network, but they were both inactive. And because they were both inactive, they're not currently visible during our proper session. Also looking at the data, which we can now see in our network. So I'm going to the drop-down menu again, doing show lines. It will give me an overview of all the pipes in the project. Looking at one of the lines on the left-hand side. I said left-hand side. There we go. This line, for example, currently carries a flow of 400 resources. The one behind it, only 100. And that's because this line, carries 300. This load consumes 300 resources. This load consumes 100 resources. So there's 100 flowing through these lines, and 300 flowing through this one, and 400 flowing through here. The lines on the other side, though they still exist, nothing flows through them, so they are not visualized. That's the general workings of networks in a nutshell. And next up, we'll be looking at how we can create one of these networks ourselves. Because I've pre-prepared this one. But we also want to know how to create your own network. Now this one I've created manually using one of the network editing tools. However, today I want to show you how you can generate your own networks. So if you have your own project, you can create your own network structure within it, and basically create an entire network for you to play and interact and plan with. So to do that, give me a moment to clear up the network that I've already created. So I have my network here. I'm going to delete all the lines that I have. The reason I'm doing... Oh, wait. I have to stop the test run first. So the reason I'm clearing my network off first is because you'll probably be starting from a project which does not yet have a network. And I want the wizard, which we'll be showing momentarily, to as closely represent your experience as possible. So we have no loads, we have no lines, we have no loads. And the network itself is inactive. So now it's as if I've never had a network ever in my project. To get started with creating your own network, you can go to the networks menu and then select the option in the drop-down menu for the network wizard, which will open this screen. Is the screen visible? Yes. This is the network wizard, and this window will help you guide you through the process to create a network for your entire project area or subsections thereof. It's composed of a number of steps. One of the first steps is to actually have an active network in your project. So basically, if you're starting from scratch, you'll be asked what kind of a network you want to be dealing with today. I like the electricity network, so I'm going for the electricity network. We have electricity, gas, heat, and internet built in. So if you have other kinds of networks that you would like to model, for example, if you're not dealing with an internet connection, but with a sewage connection, you could also replace one of these networks with your visualization of a sewer network. They all work the same. I'm picking the electricity network, and when I've done so, I will get a report that the net type I have has 0 net lines and 0 loads, which is correct because I've just removed them all, or never had any in the first place. I can choose to edit my network to change that situation, so I'm going to pick Edit Network, and this will put me on a road to generate a couple of lines, a couple of loads, given a number of parameters which will be asked in sequence. For a start, what kind of electricity function I want to use. To clarify, when we have a line in terms of network technology, a line itself can have a number of properties, but it also inherits properties from basically an abstract concept of what a line can be. So for example, you have an electricity cable, an electricity line. We have one abstract concept of such an electricity line which has a certain diameter and maybe a certain price per meter and a certain color. I like it bright yellow. But the lines which are actually created and actually placed in the world can have attributes which differ from this. For example, I can color a couple of them differently or can give them a different diameter. But any property that they do not have, they will inherit from the electricity function. In this case, the electricity line, which I'm looking at right now. So if I'm defining my network, any line that I don't give an explicit color will be colored yellow. And any line that doesn't have an explicit diameter will be given a diameter of 0.1 meters or 0.1 meters. Generally, when you select a network to be active, a pre-existing function is automatically created. So you can generally just use that one for your first network. But this is useful if you want to create a network with, for example, pipes with varying diameters and varying properties which are related to that. But you can start with the one that's generated by default for you. So this step, just select the electricity line and next. We get a question on how we want to create the loads in our project. We have a couple of options. We can do nothing, which would leave us without a network. We can import them, If we choose to import them, we'll get the question to import a number of GeoJSON files for the loads and the lines collectively. Using these options, we'll be able to load in a set of data from an external data source and import that into our project. Today, we do not have such an example set of data, so we're going to choose to generate our network instead. When you click generate, you automatically jump to the next screen. I have a... does minimizing help? I'm going to move to the side. Out of the way now? It's not out of the way. Bear with me for a moment. Yes. So in our project, we have a couple of neighborhoods. I've centered mine around the neighborhood called Ecodus, which is where I want to generate my network. Now, if you want to include multiple neighborhoods, or you want to create a network across multiple neighborhoods, that's fine. Basically, the question that's currently displayed in the network wizard is a question of which neighborhoods do you want to take into consideration when generating your network. So every home is within a certain neighborhood. We can either say, yes, includes all the homes in this neighborhood, or do not look at the homes in this neighborhood. And every neighborhood that we check here will be included in the generation algorithm. I'm looking only at the Ecodus neighborhood, so I'm selecting only the Ecodus neighborhood, and then I'm going to go next. Next question is, what kind of constructions should be connected to your network, potentially? So that by default, it includes all kinds of housing: affordable housing, market housing, senior housing, student housing, and top market housing. This is generally fine. These are all of the basically consumer kind of connections. So everything houses, no companies, no offices, no industries. Of the neighborhoods and the structures that, or the building categories that you have selected, you are presented with a list of all the stakeholders which are potentially affected or included in your network. In this case, there are two parties: the inhabitants and the municipality. I'm going to select them both. That means that the properties of both of these stakeholders is taken into consideration. Before we can generate our network, there are a couple of parameters about how to generate our network, which we have to fill in. For example, it may be relevant to group certain addresses together, depending on what kind of a structure they are in, and there are two ways of filtering that. That's through an address threshold and a floors threshold, which basically means that if a building is high enough, or if it has a lot of individual addresses in it, then it should be considered a single point of connection for your network. An individual house, a standalone house, will have only a couple of floors and only one or maybe two addresses or so, which means that they can be connected individually. But if they are like a big apartment complex, then generally that apartment complex will have one big connection for all of the addresses which reside therein. And the way to detect that would be either through the number of addresses or the number of floors. Next, it's possible to skip buildings which have already been connected with a load. This is generally useful when dealing with cases where you already have a network, but you want to add additional loads to your pre-existing network, or when dealing with the generation of multiple networks for the same addresses, both of which we won't be looking at today, but just so you know that what it does. If there is a building and it already has at least one load associated with it, then no further loads are generated for that building if you've checked this option. By default, it's not checked. The last option is important: create paths. That will actually create the network part of our network. What we've entered so far is about the loads, so the connections, the definitions at the ends. But the actual lines and where they are, that's going to be done if we check this option, create paths. Which we do, so we check it, and or rather it's checked by default, we make sure it's checked, and then we click next. Now for the generation of those paths, we're going to need a line definition of on which all of the lines which are generated are based. In this case we have one, our default electricity line, so we're selecting that one. Next we have to select where in our map is the root load, so the source of our entire calculation. The wizard presents us with a button, draw a route in map, and then the option to switch to the 3D view. And this is our neighborhood. So we have a few houses here, we have a few houses here, and this looks like a very neat entryway. So I'm going to place my root load over here. I'll pop the wizard back up. And now rather than draw route, we have the option to say show route. And the message says the root load is correctly configured. So that's okay. Then there are two parameters we can use to refine the way that the lines, that the network is generated. We have a merge range and we have a search range. Merge range generally will mean that if there are lines being generated and there is a nearby line already in place within a certain range, then a direct line between the line currently being generated and the line which already exists is created. So that basically means how quickly does it jump through obstacles to meet up with a pre-existing line or a line that's already been created earlier in the generation process. And the search range is basically a range starting from the load and then from all of the endpoints which it generates, or rather from all the nodes which it generates. Whether it's more efficient for it to look for the root load and head in that general direction, or to jump to a nearby line and head in that general direction. To clarify, the search range dictates how far it should look in order to determine its general direction, and the merge range determines how quickly it jumps through obstacles to make the final connection to its destination. Unless you have very specific ideas of how the network generation process should run, or you have a certain situation in which the default parameters don't generate the kind of network that you want, then it's okay to tweak these values. Otherwise, it's best to just leave them at their default values and you'll get a network that's generally okay. After setting those parameters, you get a verification screen where you can see what locations are viable for lines to be generated under. So you get a picture of the entire project area, and everything that's colored green is a surface for which it is permitted for lines to be generated underneath. And in general, that means like roads and pedestrian paths and things like that. Those are commonly allowed to be broken open to place lines under. Solid structures like apartment complexes or industries or offices or shops, those are generally not permitted. It's possible to adjust the function values related to that building in order to to adjust the function values related to certain types of buildings, to say pipes are or aren't permitted underneath this kind of structure. Generally, for a real world location, you will have a road network, which is a great handle for where lines or where pipes or cables are allowed to be generated. So for this one as well, This is more of a verification step. And unless you have a very specific project area, you may want to tweak a number of values or place a number of additional structures based on what you see here. But if it's a closed network like you see, then it's fine, and the lines will be able to find a route from their origin point to all of their destinations. Once we've gone through all of those settings, we'll finally be able to generate. Now this takes a tiny bit of time because this is like a single-threaded process. It can't very easily be perfectly parallelized. Is that a word? So this will take a minute or so to properly generate everything. And what it does is it first looks at all of the eligible homes that we have selected. So homes that are in one of the neighborhoods that we have selected, that are of the building type that we have selected, and that are of the stakeholders that we have selected. And it will generate loads for those buildings, for the addresses within those buildings. Next, it looks at each individual load. It'll generate a line between that load and the root load. And then it'll look at the next load it can find, which is not yet been generated lines for, and it'll connect that one to the root load. And then the next, and the next, and the next. And every time the network will grow bigger, there will be more branches, and other loads will be able to connect to those branches, and the process continues until all the loads have been completed. We can now finish this step, because the generation process has completed successfully. And we'll be cast back to the step about our electric loads. And we can see that a whole lot of them have now been generated. Where there were once none, now there are plenty. Quickly looking at how our project area looks. So I deactivated the neighborhoods overlay. It's the lines are only visible in either the default overlay or one of the network overlays. In the default overlay, you will be able to see our network. So it placed our root load here. It generated all of the loads, and then it generated lines from those loads to the root load. So our neighborhood now has an electricity network. That's nice. So this step now we can finish as well. Now we see that our network has 251 loads and 0 clusters. We'll get the clusters in a few moments. We'll also see that the general state of our network is nothing, meaning that from the outset our entire network would be disconnected. I don't want that. I'm going to set it to ready. And now, if I look at the state of my loads, not here. Going back to the dropdown and then show loads. Time state ready. So now they should all be pre-connected or in a pre-connected state to the rest of my network. We get a validation step here to check that the network as it is structured so far is, well, valid. Our network generation process works fine, pretty well actually. But it's not perfect, and sometimes there are a few situations it can't handle perfectly, like neighborhoods which are very close to the edge of a project area, and that it might clip one of the lines, or loads which are somewhere in the network, but which cannot be directly connected to the rest or loads which are somewhere in the project area, but which cannot be connected to the rest of the network because there's too great a distance with obstacles in between. For example, like a big highway or a big river that the pipes aren't allowed or the cables aren't allowed to go under. And in those cases, we would get a warning here, followed by a step of how we would want to correct those issues. And oftentimes, if it's like a line which doesn't go anywhere, one of the options will be, for example, to remove all the excess lines, leaving just the valid part of the network. Depending on what kind of an error has occurred or what kind of structure the generation process has resulted in, you will want to pick the solution that's best suited to your needs. You'll be offered a number of solutions. In this case, my network is valid, and this is what it looks like. So yay, I can go next, I can go to the next step. The next step is generating my clusters. We have a network which is composed of lines and loads, and I've left out clusters consciously, because where the net lines and the net loads are part of the definition of the network itself, the clusters are kind of a tool, a grouping that we overlay on that in order to make it easier to affect the network in a session environment. A cluster is basically a grouping of loads which can then be inspected and controlled via single instructions and single queries. We're going to want to generate those for our network, so we're going to say generate clusters. We'll want to generate it for our electricity network. There is a chance that, if you want to use networks for more expansive cases, looking, for example, at households which have multiple types of connections and therefore are subject to multiple networks, you may want to cluster with multiple networks so that you can, from one interface, turn certain connections on and certain connections off for households. In our project, we only have one network, our electricity network, so we're going to stick with that one. Again, we have to select which neighborhood we want to work in. We only have one neighborhood in our area, so we're going to select that neighborhood, Ecodus. Again, I emphasize that the neighborhoods that you select here are the neighborhoods that are taken into consideration when clustering, or in this case, when generating clusters. It does not mean that there's going to be a cluster for every individual neighborhood. It just means that we're telling the algorithm of all the loads which can be clustered, only look at the ones within these neighborhoods and disregard the ones outside of those neighborhoods. We also select the stakeholders which are relevant. In this case, we have only one stakeholder, namely the inhabitants. So earlier we had also selected the municipality as a potential stakeholder, but apparently they did not get any loads, which is fine. We only have the inhabitants which owns loads in our neighborhood. So we're going to select the inhabitants. And again, the same rule applies. It's look at the loads of these stakeholders, disregard the loads of other stakeholders. Now, there are a number of ways that we can group together clusters in a project area. For example, we have clusters based on squares or maps in the city, which basically means anything which is closely together, group those things together. We can create clusters for every individual building. We can group them together based on attributes which could or should be present in a load. It's possible to create one cluster for each separate load. It's also possible to already have clusters. For example, clusters which were generated for an electricity network, but then to have added also a gas network with gas clusters, and to then add the gas loads to the pre-existing clusters based on being in the same building as the electricity loads. Keeping my terms straight. The method that we're going to pick for now is the one based on squares in the city map. So that basically just means we're going to define like an area, or rather an indication of an area, a size, and all of the loads that are within a 400 meter radius in this case will be grouped together. So a big square of 400 meters. We'll get the option to also cluster certain loads separately. If we have loads which are defined for apartment complexes and things like that, the choice we had earlier about grouping addresses together in a single load, if those kinds of loads exist, we can choose to place those in separate clusters from all of the other clusters. And if there are loads which do not belong to any stakeholder, which can happen under certain edge cases, which stakeholder should they be assigned to? In this case, the municipality of Delft would be the default stakeholder, or municipal stakeholder in this project. So, important bit in this step is we're going to choose sectors of just the default size of 400 meters. Depending on which clustering method you use, different parameters are available here. That's all we need to do for clustering. So we can now generate our clusters. And we can finish that step. And we'll see that one cluster has been generated, containing 250 electricity loads. So apparently your neighborhood is so small that everything fits together in one cluster. Looking in our 3D world, we'll see this icon has appeared. And this icon is a cluster icon, meaning there is a cluster here, and that cluster consists of all of these loads. So, yeah, okay, all of the loads are in one cluster. That's fine. Switching back to the wizards. Yeah. Next step is again a validation step. Except now what it also validates is whether every load in the project, except for the root loads, are also clustered. If there are any loads which for any reason do not fall within a cluster, then again a warning would be presented here, and the next step would be how do you want to correct that situation. An example could be if you choose to cluster loads based on the building that they belong to, and there are loads which do not belong to a building, possibly because you've imported them or manually added them yourself. That would cause a load to not be clustered, and thus you would get a warning here. In this case, all of our loads have ended up in a cluster, so our validation succeeds and we can continue. We can now select a panel or not, with which we can control our cluster of loads. Especially when you're still experimenting with network technology, this is recommended to generate the appropriate template Excel panel. So select generate and press next. This will add a template panel to your project and also automatically attach it to your cluster. So we have our template panel now in our editing environment. In the wizard it's possible to define the width and the height of the panel, but those are mostly irrelevant, those are already tuned. Lastly, there are a couple of steps about the visualization and usage of the network as a whole. Most important two settings for now are the network approval, net owner approval required, and the direct connect first request. In general, what happens if in a real situation parties want to look at connecting or disconnecting certain units to or from a network? If there's a housing block that wants to be connected to a certain network, then whoever owns that housing block would have to say that they want to do that. But then the net owner would have to agree as well. It's not always profitable to connect all of the houses or all of the houses that want to a network because maybe the network will get stretched too thin or there aren't enough resources to provide everyone. So the net owner would have to also approve the request. That's that first option. So from the perspective of a house or a house owner, they would be able to request a connection, but then an approval would also have to be given by the net owner before they are actually connected. To facilitate more speedy planning sessions, we've also included the option to allow the first request made by a house owner to be to allow for a direct connection, which basically means that if they want to connect, they can, and they're automatically added to the network. And then both the net owner and the the house owners have permission to cancel that connection as well. And from that point onward, whenever one of those parties says they want to connect that housing block, the other party will have to agree as well, because apparently there was some discourse about it in the past. For our purposes, we're going to turn these options off for now. Next option is show cluster models. That was the figure in the 3D world that I just showed you a few moments ago. Those can be visualized or hidden. I prefer to leave them on. Show node to load lines. Those are, let's see if I can bring up one of them inside here. Yeah, so we have a couple of loads here. Can we see this? Almost. Yeah, so we have a load here, and we have our lines here. Can I? Yay, much better. All right. So we have a couple of loads here, and the line ends here. But the load is generated for an address here. To visualize what point on the network a load belongs to, or vice versa, a small orange line is visualized, and we can turn that line on or off by clicking on it in the appropriate window. And lastly, the default fraction connected. Using that is kind of out of the scope of this webinar for today. But what it means is if you connect a large group of homes, there might be some that still refuse to be connected. But for terms of discussion, you can make an assumption that, for example, 80% of those homes would be connected to the network. And thus the amount of resources that would have to be provided is 80% of the total which can be found in a cluster. We'll leave it at 1 right now, which is the assumption that everyone who's connected or everyone that is part of a cluster that is being connected will also actually be connected to the network. Finally, we can finalize the wizard and will be sent back to our editor. So now we have our neighborhood, we have our project area, and we have loads which belong to the inhabitants of the area, which should also have a panel. Now only the inhabitants can see that panel because they are the ones that have the right to decide whether or not they want to do something with their connections. So we're going to switch to the view of the inhabitants. And from the perspective of the inhabitants, there is this pop-up, which has been generated. This is the generated panel. And this panel offers them the ability to connect or disconnect their houses from the rest of their network. And we're going to do that. We're going to start a test run. We're going to say we're going to disconnect all of these houses from the network. Now test run has started and our network has disappeared. Everything except the root load, which is still visualized with a red dot here. We can also reconnect all of the loads again. And we'll see the entire network appear again. So that's already a good part of the generation of a network. I want to refine what we have right now, because right now we have all of our loads in one cluster. And I think it would be better if we can divide this neighborhood up into smaller clusters. So I am going to reopen the network wizard. That's networks and then network wizard again in the dropdown. And in the network wizard, there we go. There we go, network wizard. In a network wizard, we can go back to the step about net clusters. We have a cluster, but I don't want this one, I want new clusters. So I'm going to select the option to erase them all and to start again. And the option to select is then to erase all of the net clusters. There are no real variations to that. We'll be sent back to the option to generate our net clusters, and most of the options we're going to select are the same. So we're going to choose our electricity network, we're going to choose our ACODIS neighborhood, we're going to choose the inhabitants as our stakeholder. I still want to do it based on squares in the city map, but this time I want to make squares of only 200 meters rather than 400 meters. This will result in 4 clusters in our neighborhood. So now we have a cluster here, a cluster here, a cluster here, and a cluster here. And now I can show you a bit more accurately what the benefit of clusters are. If we have this section of the neighborhood that we want to disconnect from the rest of the network, we can disconnect this entire cluster or activate it or connect that entire cluster, and that section will be turned off. Now this section is still connected, and this section is still connected, and this section is still connected, but here the lines have disappeared. I can also choose to deactivate these loads, or this cluster. That will result in apparently these houses being disconnected, but the line still continuing on to all of the houses over there, which are still connected. I can disconnect this one as well. And now only this section of houses are connected. So to recap what we've seen so far, we've generated a network based on the addresses in our houses. Those houses all have been provided with a definition of a load, a consumption, and a network has been generated in terms of lines, which can feed all of those loads. And using clusters, we can activate or deactivate those loads during a test run. And activating or deactivating those loads will affect how much resource flows through certain sections of the lines, and therefore also which lines are active and inactive. I want to make one additional tweak here, just so that it's properly explained. Currently, we have generated panels for the inhabitants, which means only the inhabitants have the ability to interact with our network. But if we go to current situation, panels, and then look at our template panels, we'll see that's a single panel of which 4 instances have been generated, one for each neighborhood. And each of those panels has been assigned to the inhabitants. And the reason it's been assigned to the inhabitants is because it's the template panel has been assigned to use the owner of whatever it is connected to. If we duplicate this panel, we create a second one, network interaction 2, rather than use it on the owner of the networks or of the loads, we're going to connect it to the net owner. So who is the owner of the network of the loads which the cluster belongs to? And I can apply that template, generate 4 additional panels. Now those 4 additional panels will not be displayed by the inhabitants, who are the owners of the individual loads. Instead, those panels will make it possible for the owner of the network to also interact with those clusters. In our use case, that's the municipality. That means we can also now set in our network configuration, that's if I click on networks, we have the option network configuration. Under general settings, we can say now it does require the approval of a network constructor to connect to the network. If we now look at a network in which a number of areas are disconnected, so this section is disconnected, this section is disconnected, this section is disconnected, leaving only this section on the network connected to all the others. And now as inhabitants, I would want to say, I want to connect these homes to our electricity network. I would say connect. And then I get the notification that in order to connect, I will need permission from the municipality Delft, which is currently configured as our network owner. Switching to the Delft municipality, we'll see that there are 2 neighborhoods which we cannot interact with at the moment because the inhabitants do not want to connect with those. There's one section, one cluster, which is currently connected, but of which we can say we want this neighborhood or this section disconnected, we being the net owners. And there's this area where the inhabitants have said we want to connect these homes to the network now, but we need the net owner's permission. So the net owner also gets a pop-up indicating that they want to connect this section of the network to the rest of the network. And we have the option to say we want this connected, or we do not, we want this disconnected. We're going to say connect, and that will finalize the transaction and allow this section to be connected as well. This is all fun and good about making your connections with the network and having your loads turn on and off and having your net lines turn on and off. But it's also important, if you can interact with this network, to also extract data from this network. Because if you can do that, you can create your own calculation models and your own interaction panels with it. So in order to give you a grasp on that, I'm going to activate our query tool. Okay, it popped up. And in our query tool, we can create queries for our network. For example, we can say we want to select the attribute of a certain load in our network. Load 256, sure. And And specifically, the attribute that we want is the flow attribute. So how much resource does this load request? We can perform that query, and we'll get the answer that it takes up 46.767 units of whatever resource is being transferred here. I'm going to say it's either joules or kilowatt hours here. Exactly what kind of unit you want to assume pumps through your resource network, that's up to you. We do not make assumptions about what kind of units you want to pump through. So this is data about an individual load. We can also request this same kind of data from an entire cluster. If we request this data from an entire cluster, we will get the summation of all of the loads within that cluster. So we had one load which took about 46, let's say 50 of a certain resource. If we look at an entire cluster, it takes up 1,162, if we round it, of that resource. So that's the summation of all of the loads within that cluster. We can also request the state of a certain cluster. So we can say, I want the state of our cluster, which is that it is currently connected. Or for another cluster, it is currently not connected. Meaning that if we combine these two kinds of data, if we can get the flow from a certain cluster, and we can get the state from a certain cluster, and we can do that for all the clusters, it means that we can determine how much of a given resource, how many joules, how many kilowatt hours, how many cubic meters of gas, how many internet bandwidth is needed to feed this entire network. Which is important when you're deciding what you want to connect to your network and how much resource do you want to invest, and how large does your source need to be, and how wide do your pipes or your cables need to be. This is all just data about the loads, about basically the consumer ends and possibly also producer ends that are connected to your network. But what's also important is the state of the network itself, of the lines which connect all of the points. For that, we can use the length query. So select length for a given net line. And we'll get the answer, this line is 33 meters long. And also for a line like this, we can also retrieve an attribute, namely the flow attribute. And we get to see how much of the resource has to flow through that line. Apparently this line is one quite near the root because there's a lot of resource running through it. If we look for one with a higher number, that's lower. One with a higher number, this one is one near the ends. It only has about 30 of that resource running through it. But the fun bit is, if all of the if we say that our lines are all disconnected, disconnecting our lines on the background right now. If all of our clusters are disconnected, I should say, then the amount of resource flowing through a line will be 0. That means that we can also retrieve how long certain sections of pipe or line should be, and how wide they should be, and if they're 0, they don't need to be at all. And that means we can also calculate how much does it cost, or how many, basically how much does it cost to create and maintain the entirety of the network. And these are the bits of information that you need to determine whether a network is viable or not. That's the basics of the network technology as we have implemented it so far. What I would like to leave you with is the handles for how you can make this technology work for you. What I want to give you is the fact that when you have these panels, these are default panels as generated by the Tygron platform and as instance based on your specific network topology and settings. But using the debug Excel sheet option or even downloading it via select Excel sheet, it's possible to download a copy of that Excel sheet and inspect it yourself. And although I will give that it is one of the more complex default Excel sheets that you can find in our software, it is possible to run through it and deconstruct it and take from it the bits that you might need to create your own panels to control the network with and to retrieve data which is relevant to the entirety of your network. I've been having a bit of trouble getting Excel to display properly using my current stream. So I've done it the low-tech way and taken a number of screenshots from my Excel. I can almost hear you giggling through the microphone. There we go. So a few bits of the Excel that I want to highlight is that there is a section about properties of the cluster that are retrieved from the cluster. It didn't come out right. There are a number of cluster properties that are retrieved from the cluster and placed in the Excel to determine the state of the panel width. So for example, we have in, my mouse isn't highlighting anymore, that's a shame. We have the name of the cluster with the cluster ID, we have the current state, we have the owner, a couple of properties on the cluster in general. A bit further down, we have some data on the contents of that cluster, on the net loads which are part of it. For example, we have the amount of loads which are in the cluster. We have the amount of connections which are part there. We have the costs of all of the net loads together. So if you're going to connect this cluster, how much is going to cost collectively? How much of a resource are they going to request collectively? And in the top you can see that the query we use here is basically the same as the one we just constructed in the query tool. That's select attribute where the net cluster is and then whatever the idea is of the net cluster. And the attribute name you're looking for is flow. And it will return the summation of the flows of all the net loads within that cluster. Meaning that you can get a report in the Tygron platform about which loads are or aren't taken in there and what it would mean if you connect or disconnect the entire cluster. Lastly, if you're creating your own system for interacting with the network, then I would also recommend looking at the tab of action buttons, which is where we have placed the structure for all of the interactions that a stakeholder can make with a specific cluster. So all of them are defined in the Excel, and based on the state of the cluster and the panel and what stakeholder you are, some options are or aren't displayed, but all of the structures can be viewed in the action buttons tab, and it's all HTML forms which make a call to a specific URL, a specific event call, which is an instruction to say attempt to connect this cluster or attempt to disconnect this cluster. And depending on the state of the cluster, that would mean that either it's connected directly or that it would request permission or that it is disconnected directly. And so on. So those are three important bits to look at if you want to take pieces from this panel and construct your own with it. And left as an exercise to the reader. These are also the kind of bits that you would want to look at if you're going to construct your own indicator for calculations of the network as a whole. That's also one of the important caveats or point of attention that I want to give you with this one. We do have the network technology and we do have the tools to interact with your network. What we currently do not yet offer, due to its complexity, is a full means of doing network-wide calculations and basically producing indicator results based on that. In our experience, the use cases in which networks are used always require very specific output, and it's very difficult to catch that in a default indicator. So when you're going to approach this from your use case, although we do recommend you're starting with deconstructing the panel that we offer, I do recommend starting small and then building up to the use case that you want to cater to specifically. That, in a nutshell, is everything that I wanted to tell you today about networks. So I've given you an overview of the components of what makes up a network and how they work. I've given you a step-by-step description of what happens in our network generation wizard, which helps you create your own network if you so want. And I've given you a few pointers as to how you can work with the interaction with your network and what kind of bits to look at if you want to create your own calculation models. If you want to go on further with this topic, there are a few additional reads that I would recommend. I would recommend that you look on our support wiki for our further documentation on networks, including how to manually create bits of your network or what kind of data format we expect if you want to import it from a pre-existing data source. I also recommend that you look on our page concerning Excel if you want to create your own panels and indicators, together with looking at and experimenting with TQL, again, for creating your own indicators and your own interaction panels. And additionally, I would also recommend looking at our webinar given a brief while ago concerning TQL and indicators, which dives a little bit more deeper in how you can use TQL to create a properly structured indicator and to use it to create a metric on which to score a topic such as network efficiency or network cost. So that's everything for today. I hope you have enjoyed my webinar and I hope you found it productive and educational. We will be uploading it to our YouTube channel in a little bit, so you'll be able to watch it back. And I hope you all have a good day and enjoy working with our networks. All right, see you around.